Okay, perfect. Well, thank you everyone for joining. And in this meetup, we're going to see how to start in Hyperledger Fabric, but from the operations point of view. This is like a yearly meetup that I've been doing for this is the third year. And let me, okay, slide so better. So this is like the third year that I've been doing this workshop where we go and deploy a Hyperledger Fabric network. We do it with the Bevel operator Fabric, which I'm the main maintainer of that, and a bit about me. So I'm David Viejo. I work at Kung Fu Software and we're specialized in Hyperledger Fabric. We have been working with Hyperledger Fabric for 3-4 years. So we only dedicate to that, to Hyperledger Fabric projects. We're the main maintainers of the Hyperledger Fabric operator, which is what this workshop is about, in order to deploy networks, deploy Fabric networks in Kubernetes efficiently and fast. And this is my LinkedIn in case anyone wants to reach me out. Feel free to do it. So let's jump into some context about Hyperledger Fabric. So for people that don't know it, Hyperledger Fabric is a blockchain product that is permissioned. So this means that not everyone can use this network. So we need to give them some kind of access. So in sorry. So in this network, there is a consensus, and in Hyperledger Fabric there is pluggable consensus, as we can see here, which allows for different methods of reaching consensus. I did a meetup on Hyperledger Fabric 3.0, and right now there is only one consensus, which is Raft, the Raft protocol. But in Hyperledger Fabric 3.0, there will be a BFT, a Byzantine fault tolerance consensus. So this pluggable consensus will make sense in the next major version, which will be 3.0. Hyperledger Fabric supports smart contracts, but they are called chain codes, and they are regular programs that are written in Go, JavaScript, or Java. And this makes it very easy for people that are outside, for developers that have been developing with normal languages, because usually the language for the blockchain networks in Ethereum is Solidity. But in this case, there is no need to learn another language. So you can use it with the regular language that you are used to use on a daily basis. So it allows the creation for private channels. So imagine that we have a network and we want to make a network between three organizations. So this allows the possibility to only these three organizations will be able to access this private blockchain network and will be able to interact with the smart contract. So, and also imagine that we have three organizations and we want to share data in a subset of participants. So we need to build a sub-channel, let's say for now, among a subset of the participants. This is also possible. And this is possible with the private data collection. So these are some concepts. If you are new, this is very hard to process in just an hour and a half or some minutes. So you will see this. For the private data collection is something that you will understand when you use it. So right now, the idea is that we have a permission network that only the participants that are authorized can see and access the network. In order to modify the data, we use smart contracts, and we have channels in order to form consortiums. Consortiums or agreements in order to have a network to deploy smart contracts and to exchange data. So that is what Hyperledger Fabric is about. Of course, this is open source, so and highly configurable. It has many parameters. So the context for this meetup is when we started the meetup, we started in Hyperledger Fabric 2.3. Right now we're in the Hyperledger Fabric 2.5 LTS, which means that this is the long-term supported version. And we will use channel participation API. And to give you some context, when I started in Hyperledger Fabric 2.2, there was this system channel. And in order to create a channel, you needed to create a system channel first, and then you created the application channel, which was called. And this introduced a new step because creating a channel is not easy. So channel participation API was introduced in 2.3, and now is the preferred way in order to manage networks. So 2.5 LTS will be used. The operation, all of the operations will use the kubectl plugin from the Hyperledger Fabric operator. This is a plugin that is specifically built for kubectl and allows you to interact and has a specific logic to connect to Hyperledger Fabric networks. Then chain code as a service will be executed using Kubernetes. This basically means that we will have the smart contract deployed as an external service, and the chain code is just a regular server, and the PR will connect to the chain code. We will see the PRs orders in the future slides. Code can be found not here in the link that I sent in the chat, or scanning this QR code. And we're not using CryptoGen, where everything that we will do will be automated using the operator. But in order to understand the automation, we need to understand the concepts. So we have a peer. And maybe there is yeah. So these are the components. I will start here and then come back. We have three major components in a Hyperledger Fabric network. We have the PR, we have the orderer, and we have the chain code. These are the three. Everything else are, we have the SDK client, which is the component that connects to the network. But the network is composed of these three components. We have the PR, which, okay, let's, here. Okay, I pasted the link in the chat for the repository. So we have the PR, and the PR belongs to the PR organization, and the orderer belongs to the order organizations. There can be organizations that have multiple nodes of this type. So there can be organizations that participate in the consensus, and the orderer nodes are the ones that participate in the consensus. And there can be organizations that participate in both, in the execution of the chain codes and in the consensus. So usually, and this is to have high availability, we have three orderer nodes because we're using the RAF consensus protocol. And this, in this case, in this meetup, we will create three orderer nodes, and we will have one orderer organization, which we will see later. And the PRs will be the one that execute, that connect to the chain code. So each PR organization will have one or more PRs, and they will need to deploy the chain code. And the chain code is the component that contains the smart logic. So when you see chain code, you can translate it to a smart contract. And each of these components have TLS certificate and sign certificates. So this is the global picture. Let's come back to the PR in order to see the characteristics. And maybe I'm going too fast, but if you have any question about the concept, about everything, just drop it in the chat. I have it side by side so I can see any questions in Zoom. So the PR is another participation in the execution of the smart contract. So whenever there is a transaction, the PR needs to be involved in this transaction flow. A question from YouTube: does the external chain code support other languages? The external chain code supports Go, Java, and JavaScript. So, and yeah, of course, uh, Go, Java, and Node.js. So you can use JavaScript or TypeScript. I think TypeScript is better because it allows you to have typing and everything. SDK is now the Fabric Gateway. Yeah, we can explain that. I mean, depends on the level of the audience. We can explain that in the future, but you can use both. So what the gateway did is move this flow that you need to go to one peer or multiple peers and then submit the transactions to the consensus, to the ordering service. Yeah, left of Python. So these two arrows are the ones that are replaced by the gateway service, which runs in the PR. Because what ended up happening is that this SDK client was in Java, was in JavaScript, was in also in Go, and I'm sure there were inconsistencies. So one bug that was in Go needed to be ported to Java. So what they did is, okay, let's migrate all of the functionality and let's make uh, a service that can collect endorsements and submit the transactions to the ordering service. And this was included in the PR. So right now, the SDK client just invokes the PR, and that's it. And the PR is able to endorse the transactions, invoke the chain codes, etc., and then submit the transactions for the orderer to finalize the block. So this is the idea. For Sergio, who asked this. So let's go for the PR. As I said, the PR is participates in the execution of the smart contract, so participates in the transaction flow. A PR can act as an endorser, so this means that if the smart contract is installed in this PR, then it will be able to endorse transactions and to execute the smart contract. If not, then the PR will, if it's part of the network, then it will receive the blocks, and that's it. So you will maintain a copy of just a copy of the ledger, which is a valid option. Imagine that you have a network and you have multiple peers, and you want to have a separate peer in case something goes wrong, as a backup database. So this is a valid use case. So that PR will only receive blocks from the ordering service and but will not execute any chain code. So the PRs also maintain a copy of the current state of the ledger. So and can update the state based on valid transactions. So this is the concept of the state database. So and maybe I can do a diagram about this. One moment. So a PR, we have the PR, has two parts. Has the state database, which can be LevelDB or ChaosDB, and it has the storage of the blocks, which is just storing the blocks in raw in the file system. And what this is called in the GPL Fabric documentation, this is the ledger. So the combination of the state database and the block storage. So imagine that we have key one written to the ledger equals B1, and we have another transaction later, which is key one equals B2. In the blocks, there are two transactions, the one that says key one to B1 and the one that says key one to B2. But in the state database, only the latest one is stored. So key one equals B2. So you can imagine that the state database will be much smaller than the block storage. And why we have the state database? Because in order to query simple values, so most likely we will want to obtain the latest value of a key. We don't care about the history. But if we care about the history, we have another database, which is the history database, which is in, I think it can be, It's in LevelDB for sure, but I don't know if you use CausDB, it will be in CausDB. But it's basically a database that stores all of these uh, transactions, all of the modifications. So in the smart contract, you can query for the history of a certain key. And this will give you that the key in uh, had the value v2, which is the latest, and then the value v1. And this is also stored with the transaction date. I don't know if you have the block. So you have some metadata, extra metadata. So these are the storages that happen that are in the PR. Okay. So and this will be stored either if it has or not chain code installed. So this is static. So let's continue. So okay, so peers can be configured to operate in different roles, such as anchor peers, which are used to anchor the organization to organizations or channels. So anchor peers, and we will understand this better when we see the channels. Anchor peers are well-known peers to the channel. So if we go back to the diagram, we have here a channel that can have channel demo, for example. And then we have PR01 for the organization 1 and PR01 for the organization 2. So in the channel, there is the data for the peers that need to be well known are stored so that when PR01 joins this channel, then it has a reference in the anchor peers that the organization 1 has PR01 or 1. And then there is another record for the PR01 or 2. And this is how peers know each other. And then there is a discovery service that uh, uh, basically all the peers start to talk to each other, and then there is a view form where if the organization of one had another PR02, then based on this PR, then it will know this PR, and then the organization 2 will be able to know this PR and also this PR. And this is called discovery service. Okay. But this is more advanced, but I wanted to give you a quick view about the channels and why anchor peers are mentioned here, because there are many times where most of the problems happen because we don't have the right anchor peer set. So keep that in mind. So let's continue. So one of the questions that you could ask, so why a Kubernetes operator? When I started in Fabric in 2020, there was this, I'm sure that you know about, the Fabric samples, which is a great way to get started because with one shell script, you can spin up a network in Docker and you can start developing easy. But uh, when I launched the first network, it was hard for me to understand everything, and it was very hard to add organizations, to add peers, etc. Add orders, add chains, add channels. So I thought that maybe because all of the networks were deployed in Kubernetes, so I discovered this concept of Kubernetes operator, and I found that there was a way to abstract most of the logic that happens behind the scenes of deploying Hyperledger peers order to manage channels also. So just what a Kubernetes operator does is abstracts the logic, in this case of creating href components, and you just create a YAML, just like when you go to Kubernetes, you can create a deployment, a service, an ingress, etc. So you just declare what you want. So I want a PR with the image uh, pointing to this Docker registry with these resources from this organization, etc. And then the operator takes care of deploying this for you. And then it deploys whatever it needs. So it deploys a deployment service, it creates a gateway so that you can access it from outside, it creates the certificates, etc. So the idea of this is to make it easier to deploy networks and to expand the network. There is an abstraction from the initial bootstrapping of the node. And what is good that it works on Kubernetes is that you can deploy it on premise, on cloud, doesn't matter. So as long as you have a Kubernetes operational, you can use this Hyperledger Fabric operator and it will work. And it's customizable for specific use cases. For example, the certificate renewal, which was implemented with this with the latest versions. So you can configure the operator in order to renew the certificates automatically, which is often a task that is overlooked, and there are many networks that end up with certificate expired. So this is a great use case. So we saw this picture before, but basically let's uh, let's explain it again. So we have the PR, which has these two certificates, the TLS certificates and the sign certificates. Now, for more context, the sign certificates are used in order to endorse the transactions, and the TLS certificates are used in order to communicate with other peers. So the peer will have the TLS certificate in order to spin up the server, which is in gRPC, and then other peers will be able to communicate. So that is why we need TLS certificate and sign certificates. And the same happens for the orders. We have the TLS certificates and then the sign certificates, which are used to sign data, which can be finalizing signing the block or signing the a transaction no, but signing some data in order to be able to verify it later. And then we have the SDK client, which only has the sign certificate. So these sign certificates will be the certificate of the user. And this is what the certificate and the private key that will be used in order to submit the transaction. This is using the SDK client, but if we go through the gateway service, which Sergio mentioned earlier, we will also need the sign certificate in order to sign the data of the transaction that we want to execute. So the other component that is very important is the orderer. And the orderer, we need to have multiple orderers for the network to be highly available. So usually we have three, and the consensus that we will use will be Raft. And what the orderer node is receive transactions from the clients and orders them into a block. There is some logic that needs to happen there. For example, we can configure for a specific channel the maximum number of transactions that can happen, that can be bundled into a block. By default, is 10, but we will say that we can increase this number. Then the orderer node broadcasts the block to all of the peers in the network. So before there was a state gossip protocol which was deprecated not long ago. But right now what the peers do is subscribe to the orderers in order to get the latest blocks. So that means that the orderers will need to have the copy of the ledger, the full copy of the ledger will need to be on the orderers. And this ensures that all of the peers have the same copy. And the orderer service is also responsible for maintaining the consistency and the security of the ledger, so it will validate the block and the data in order to be a valid one, basically. And the order service can be either a single node or a group of nodes. If you spin up a Hyperledger network with one node, for a short period of time it can work, but if you want to if you want the network to be scalable, then you need at least three. Because if you have one, you cannot, in my experience, you cannot scale to three order nodes. So that has been my experience here. And we have a Fabric CA. So the Fabric CA is a server that was developed by Hyperledger Fabric and is responsible for issuing and managing the certificates that are used. No, in a Hyperledger Fabric network, yes, but specifically, uh, specifically there will be a Fabric CA, a Fabric Certificate Authority, per organization. So how this, one moment, I need to drink water. How this Fabric CA works. So first we initialize this Fabric CA, and we initialize it with two certificate authorities, the Sign Certificate Authority and the TLS Certificate Authority. And there is a Will Thread Manager be used instead of Fabric CA? At the moment, no, it cannot be used, but you can bootstrap I think you raise an issue on the HPLF Fabric Operator repository, but you can, in the latest version, you can bootstrap the Fabric CA with custom certificates. So in theory, you could do a custom integration, generating the certificate authority with Cert Manager and then including that in the Fabric CA. But basically, also we initialize the Fabric CA with two certificate authorities, and then based on that, we can register users. And then these users, we register them using the initial user and password, which is called the enroll user and enroll password, and then we create another user. And this user can be a client, can be a PR, can be an orderer. These are the three types of users. And there is also the type of user that is admin in order to manage the network. So we register these users and then we can enroll the user. So basically what enrolls means is that the client generates a private key, and then there is a certificate sign request. This certificate sign request is sent to the Fabric CA. Then the Fabric CA signs this CCR and then returns it. So how this will look will be like this. Moment. So we have the Fabric CA. It has a database which can be SQLite. And then the enroll, there is a initial enroll user and enroll password. Then someone needs to register the user. Admin goes to the Fabric CA, registers user, client one, client PW. And then the user creates, so there is a creation of CCR, certificate signing request, and then the CCR is sent to the Fabric CA. Okay, and then the Fabric CA signs it, and then it will return to the user, return the certificate. So this is the flow. The Fabric CA is deployed in the Kubernetes clusters, and SQLite is the default one, but you could also use Postgres. Okay, so you can choose between Postgres, SQLite, and I'm not sure if you can use any other. These are the to database that I tried. There is a question. You mentioned that peers subscribe to the orderer to receive update. Does this subscription to the orderer by peers replace the gossip protocol for propagating updates to the chain? No, because this is only for the blocks. This is a question from Jeff Browsell. This is only for the blocks. So if you have private data collections, which in order to illustrate the private data collections, we have the channel demo. And let's say that we have two organizations, okay, with one PR. This is the organization one. And we have also the organization two. So private data collections, if we check the block structure, we will see that the private data collections are not safe into the block. Only the hash is safe into the block of the private data collection. And also the key is hash. So if we have a private data collection, key one, B1, what will be greeted to the ledger will be hash key one equals hash B1. Okay. And there is a private store in each PR. So what will end up happening is that these private data collections, when we execute the smart contract, will be stored in the private data store of each of them. And these two peers will, well, basically the peers will start contacting other peers, and then if they are missing some private data collection, then they will be fetched from the other peer. So that is the main use case that I have seen about private data collections, about the gossip protocol, sorry. Then the peer will fetch. I was referring to the chain itself, actually not the PDC. Yeah. Okay. So this is the flow of the Fabric CA. This is the flow for the private data collection. Let's continue. So the CA node provides an enrollment service that allows entities to request and obtain digital certificates. So this is what we just saw. And the CA node also provides a revocation service. It has a CRL, a common revocation list, that it can be used, but then you will need to replicate it through all of the nodes. And I think it's very complex I mean, if you have a breach, it would be recommended, but I haven't seen any network that uses this because you need to restart almost all of well, I'm not sure if you need to restart them, but you need to propagate the CRL through all of the network. And maybe there are some nodes that are not hosted by your organization, and they need to be updated in another organization that has other policies. So it's complicated, the revocation, but it supports this service. So what, and we're getting into the Kubernetes, into the Kubernetes operator, so into the HLF operator resources. So there are two kinds of resources. There are the physical, which are the ones that end up deploying an actual deployment in Kubernetes. So, for example, the PR, order, certificate authority, these are all components that are deployed. And there are the logical resources, which are used in order to automate some operations. So we have the Fabric main channel, which is used in order to create a channel. We have the Fabric follower channel, which is used in order for PR organizations to join a specific channel. We have also the Fabric network config, which is used to create network configurations for Fabric based on the current organizations and PRs and orders, etc. So instead of having to build the network config manually, we can use the Fabric Network config. And it has also support for external peers, external order organization, and order nodes, etc. And we also have the Fabric identity, which the Fabric identity automates all of this flow. So if we move this, let's move this. So what the Fabric identity automates is this flow. So first, the operator registers the user. This is optional. And then it enrolls the certificate. And this is stored as a Kubernetes secret. So instead of being the user, the shelf operator gets the certificate and then it creates a secret. And not only that, but it manages the auto certificate renewal. So this, and we built it because this was a common use case for when the certificate expire. The users by default expire in 1 year, but what the operator will do is that 30 days before, and we can see this in the workshop, it will basically auto-renew the certificate, create a secret, and then also the Fabric Network config can reference an identity created by the operator. So, and the network config is updated every 1 minute, and then it generates another secret, which is the network config secret. So using this Fabric network config from the operator, you will be able to have an up-to-date with no certificate expired network config. So this is really great. And yeah, these are the two types of resources. We support the operator UI, which is a UI that we have developed, which is specific to Fabric, and it will show some channels, also the data for the channels. This includes the anchor peers, the channel configuration, the order, the peer organization, order organization, and also the blocks and the data for the blocks. And we support also the Fabric Operations Console. There is a tutorial. The reason why that tutorial might be out to date is because I haven't used it. I implemented it because this was something that was useful, but this is not really 100% tested. This Fabric Operations Console was developed by IBM, and well, if you want to make to only see the network, so the blocks, etc., I think the operational UI is very easy to deploy because it integrates also with the Fabric network config. And then the Fabric Operations Console is for more complex use cases. So we have a question: can we use a shelf operator to deploy to a cloud solution like AWS or DigitalOcean? Yes, as long as you have a Kubernetes cluster, you will need to configure some parameters, the storage class, for example, your DNS. That is the most critical part, but you can deploy it in any cloud provider that you can, say, provision a Kubernetes cluster. This was a question from George. So this is how well, there was an answer for Martin, yes, but there is currently an issue I'm facing where you can use private subnet-based clusters. I'm not aware of this issue. I mean, I have been able to deploy it in Azure, AWS, and on-premise. So, well, if you think there is an issue, then I mean, it should. If there is an issue deploying it in private subnet-based clusters, this is probably because of the network configuration. Because as we can see in this picture, what the shelf operator does is deploy these components. So deploy the peers, orders, Fabric CA, but if the configuration for these components, the network configuration is not right, then it won't work because when creating the Fabric main channel, the operator will try to connect to the peers through the domain, and then it basically won't be able to reach neither the peers, neither the orderers, neither the Fabric CA. We have another question. Now we can deploy it with hyperledger Babel using HLF operator. Is there any issues with operator deploying it this way? When I talk about the HLF operator, I'm talking about the Babel operator fabric. And I'm maintaining the operator, so I don't maintain Babel. In theory, yes. In theory, with the Babel 1.0, you can deploy it using hyperledger Babel, which also can be used to deploy other networks. I'm aware. But I'm sure that the hyperledger Babel has done an incredible job, so I think that it will be supported. The only way to deploy resources with the HLF operator, this is another question, is by using kubectl HLF. Is there a way to use the API? Yeah, in fact, I have a post in LinkedIn when I explain this moment. Basically this one. So how to use Babel operator, I will paste it in the chat. But you have the source code here. So in order to use Kubernetes as the API. So this is the Go. So we're using the operator client. Basically and this was this slide. So all of these resources that you can see here are just YAMLs. And these YAMLs are the declarative way that we were talking about. So there is a YAML for creating a peer, a YAML for creating an orderer. So what the kubectl does is just makes it very easy because almost all of the parameters are by default. Some of them are compute, but at the end, the kubectl HLF uses this operator client. And then in this case, in this example, what we're doing is first looking at the kubeconfig. This is Go, by the way. Then we're getting the HLF client, and then we're listing the peers. But same way as you can list the peers, you can create a peer, you can delete a peer, you can list orderers, etc. So it's something that is supported, but you will need to deal with the complexity of doing this. So okay, so let's continue. Any other question? Maybe from YouTube. I'm not looking at YouTube, so maybe there is a question from YouTube that I'm not seeing. Let me check. Okay, there are no questions, so let's keep going. So recently, and this was 2 days ago, so we have released 1.10. So this introduces new resources and also some bug fixes, but the major ones are the Fabric identity. It has been the renewal has been configured, the automatic renewal, of course. Then the Fabric network config, this has been expanded because now we can add external peers, external orderers, and this is useful for some companies that are using the operator in order to manage the network config, but they have multiple clusters. So all the configuration of the peers cannot be fetched from the current Kubernetes cluster because there are in others Kubernetes cluster. We have which version of Hyperledger Fabric supports 2.5. So there was a question from YouTube. So and also for the enrollment and Fabric CA, not now they support external secrets. So you can initialize a Fabric CA with a certificate authority that has been generated offline. This was also a feature that was needed, and minor bug fixes. So I, I was almost all of them was me testing it, but there were some bug or small bugs that happened primarily on the Fabric main channel and Fabric follower channel. So this has been addressed. So this is the new version. So what the skills, and we're getting close to the workshop. We need to know about cryptography, because as we saw, every PR and every order, every component in a blockchain network has cryptography involved. By cryptography, I mean signing data, encrypting data, etc. In this case, signing data is the main use case. We need to know about Kubernetes. So if you don't know about Kubernetes, I recommend you seeing a video or doing a mini course on Kubernetes, because deploying the network is 10%, but understanding what we have created and seeing what can go wrong, what can be improved, etc., is the 90%. So I recommend you looking at Kubernetes. Then we will need Docker in order to deploy the chain code. We need Node.js with TypeScript. This is in order to develop the chain code. I don't know if we will have time. I will try to focus a lot on the operations point of view. And basic networking concepts. So DNS, TLS, just the communication. And this is very useful because usually when we deploy a Happy Life Area network, one of the critical parts is how the users will access it. So in this case, we're using Istio. So if we go to the black diagram, so this is, I don't know if I have a picture here. Well, but let's do it. So the architecture that we will do in the workshop will be this one. So we will have ourselves, we're the user, and we will connect to the Kubernetes cluster. The entry point of the Kubernetes cluster is Istio, which in Kubernetes is an ingress controller. So it's the one that manages, is our ingress. Is the entry point of when we try to access a service on the inside, then Istio is the load balancer. And then we will have PRs, we will have orders, and we can have anything we want here in the Kubernetes cluster. We can have APIs that you deploy in order to connect to this order and also the PRs. So, and Istio will connect to each of them. And there are rules that can be set in Istio, so it's highly configurable. So if this breaks, which most likely is what happened to Martin, which had problems with private subnets. So if this breaks, if any of this communication is not working, then the network will not work. So this is and also apart from these components being deployed, we will have also the HLF operator, which is deployed inside the cluster. We will have the chain code deployed, etc. And then the PR will be able to communicate to the chain code via the networking inside the cluster. So this is the architecture. Of course, we can have monitoring, but this is not really in this meetup. There are courses for that. So this is not covered in this workshop. But this is the idea. So what we want to do in this workshop is create two organizations, and what we will do is uh, first we will deploy one organization and with the orderer MSP, which will be the orderer organization that will host the three orderer nodes, and then we will add the second organization because most of the problems that arise is okay. I have if you finish this workshop as it was the last year, I have a network with two organizations and two peer organization and one ordered organization. Okay, right now, how do I expand it? So let's do first creating one organization and then we create the other. Each organization, each peer organization will have a chain code and will have two peers. And then we'll have the SDK client with TypeScript or with the kubectl plugin, but it doesn't matter which will execute transactions. So, and demo time, but let's answer some question and then let's jump into this. A question from YouTube, which version of Hyperledger Fabric it supports? This was answered, but it is 2.5. But it also supports 2.4 and 2.3, but I don't see a reason why you need to deploy lower versions. Instead of Istio, we could use Nginx, correct? I haven't tested it, and in fact, one of the major features that I haven't mentioned is about the traffic support. It's not documented as of now, but right now you can use Istio and traffic. Nginx, I don't think is supported. I mean, you will need to do your own research for this because uh, I think that Nginx the support for the SNI, the subject uh, name indicator, is very poor in Nginx, and I think the Nginx ingress controller doesn't have any much support for that. Okay, the replace. Okay, so this was a fix on the weird. Okay, thanks for that. Also the chain code, thanks Martin for the pull request. Also the chain code deployed on the peer, should it be deployed as a service or it doesn't matter? The chain code should be deployed as a service, and this is the recommended way. Before, what happened is that, first of all, the peers were deploying Docker. Okay, moment. So the peers were deploying Docker, and what ended up happening is that the PR end up deploying Chainco 0 behind the scenes, and this happened on Docker. So this is the Docker daemon. And this can be another chain code. So chain code 0 and chain code 1. Okay. But this had a problem because, first of all, Kubernetes dropped support for Docker. Now the one that is supported is Containerd. So this is the first problem. Most of cloud providers don't support Docker. And the other is that if the PR deploys in the same, and this happens in Kubernetes, of course, in the same node, the chain code, then there is no observability. So basically, you cannot know if a chain code is up, is down, how much resources is wasting, is consuming, etc. So this was the problem. So the chain code should always be deployed as service. And what this means is that there is a port here, which is 7052, and then when we install it, we tell the PR to which server it needs to connect at, and that's it. In theory, this could be developed in any language, so in Rust, in Python, but only Java, Go, and Node.js are supported. Okay, so there are no more questions, so let's move to the workshop. Okay, so the workshop is located. I will paste the repository here. Okay, there's another question, but the chain code could be deployed as a separate Docker service. Yeah, you can deploy it in your local without Docker uh, with the right parameters. So yeah, okay. So you can the instruction to run this is everything is in the README. So feel free to start it to give a start here, and all of the steps are enumerated here. So we just need to copy, and what I will do is execute these commands, and then at the same time I will explain what these commands do. I will also paste this on YouTube just to make sure. Okay, perfect. So when I have this cloned into my repository, to my local, I have some files which I will remove. Okay, this crystal is not needed. And then let's start in an empty folder. So the first part, the first thing that we need to do, and I think I will be switching to this diagram in order to explain some things. So we need the Kubernetes cluster. We have two options for this. We have the K3D and the kind. Lately, I've been playing with K3D, which is just a wrapper around K3S, but you can use any distribution, any Kubernetes provisioner that you want. But one thing that we need to know is that we need to expose, in this case, we're exposing two ports. So this is the port on the host, the 80 in this is the port on the host, and this is the port on the Kubernetes. So what this will do, this is, okay, this is us. So why we need this? Because we want to be able to access uh, locally. So if we deploy a PR that is PR0 or 1 localhost.st, which is the domain that we will use, and why we'll use this domain, because if we access Google, the DNS, then we can use the domain and then it will be redirected to basically to the loopback IP. So when we type localhost, we type this IP, this domain and 443, then what we want is to go to Istio, which will have the port, these two ports open. So 30949 and then 30500. So, and the port on the host will be these ones, and then they will be connected to these ports. And this is why we need the mapping. If you don't do this mapping, if you provision it using another, I don't know, K0S, and you don't do this mapping, then this workshop will not work. And the reason why we need to do that is because we need this domain. We need basically a qualified domain. And if not, we will need to do a bunch of stuff, manual stuff that will not indicate and will not be close to a live environment like AWS or Azure. So this is the first thing that we need to understand. Let's create a cluster. Okay. This will take some time, and what this will do is create this cluster, this Kubernetes cluster on Docker. Okay. With two agents, and if we are using kind, then the same is needed. So we have this extra port mapping. 309 and then the same for the TLS. So right now we can do kubectl get nodes, and then we have the three nodes ready. We can see that the Kubernetes cluster was just created, and we can do k3d kubeconfig get. This is the number of the cluster as we have specified here, kts hlf, and then we can save it into a kubeconfig, and this is our kubeconfig. If you want to use it, for example, in the example of accessing, well, I think we removed it, but there was someone who asked how to interact with the operator using Go, so you can use this kubeconfig uh, file in order to interact with Kubernetes cluster. There is a question, can we use Minikube for Kubernetes on Docker desktop instead of K3d? I haven't tested. So what I use locally is K3d or Kind. It should work, but you will need to check if these port mappings are available. If they are available, then I think that there will be no problem. Because you will need to change some parameters that I will mention during the workshop, but they will be okay. So next part, we will need to install Istio. So if we go back to these diagrams, and I will copy this diagram, okay, put it here. So right now we have provisioned the Kubernetes cluster, so this is done, and then we need to provision Istio. So in order to do that, we need to download Istio and then add it to the path. Okay, then right now it's downloaded. We add it to the path. This is the folder that I removed at the start of the workshop, and then we have in the bin this Istio CTL. And this binary, this program, we will use it to initialize the Istio operator, because at the end, Kubernetes operator are a common pattern in Kubernetes. If you have been working with Kubernetes for a long time, you must, this will sound familiar. And okay, so first we need to install to create the namespace, Istio system, and then in order to install the Istio operator, then we need to execute this command. And in order to visualize the cluster, I use Lens. So this is a tool that you can download. I think it's Lens Kubernetes. Okay, this one, kts-lens.dev. So highly recommended. You can explore any Kubernetes cluster, and it's very fast. So this is what we're going to use in order to visualize what has been created in the cluster and in order to troubleshoot problems if they arise. So let's get into that. Connection refuse. Okay, retry, and we are in. So there is a namespace that has been created, which is the Istio operator, and the Istio operator right now is ready. At the left, we have the custom resource definitions, which are the ones that are used. Basically, these definitions are the ones that are used to quote unquote extend Kubernetes. So we will basically notice this when we install the shelf operator. But what this Istio operator has created is the Istio operator resource, which right now we don't have any, and this will be used in order to install the Istio Ingress gateway. So the next step is create this resource. So the API version install istio.io, which is the one that we have seen here, install.istio.io. And then we will create a kind of Istio operator. This is the metadata, the namespace that we have just created. There are some add-on components, but I won't get into this, but because you can install Grafana at the same time that you install the Istio gateway. But the important part is this one. So in the components, we have ingress gateways, and we're going to have one is enabled, and we're going to have two replicas. This is for the deployment, and this will be the resources. So if you deploy this in a production environment, you can tweak these resources and the number of replicas. I recommend at least two. And then the service. And this is where the mapping comes in. You see that we have that the node port is 3949, and this is needed in order to in order for this mapping to work, which was here. Well, was yeah, it was here. So this is where we declare when we were creating the Kubernetes cluster, we declared that the port 80 and 443 will be redirected to these ports. But now we're creating Istio and we're telling Istio, okay, you need to listen in these two ports. And the first one will be for HTTP and the second one will be for HTTPS. And the service type will be node port. The name of the Istio will be Ingress Gateway. And one moment. So the name of the ingress will be Ingress Gateway, and this will be the ports. Then the pilot, this is for the not really sure because this is something from Istio, but I think that this is to manage the configuration. So in this case, we can have only one replica, and the resources are very minimal. So with this is fine. So let's execute this kubectl apply. And what will happen, sorry, is that a resource will be created. Right now, the status is reconciling. These are the list of Istio operators. So you could have multiple gateways. And the Istio operator will deploy the ingress gateway. The same way that the HPLI Fabric operator, when we create a kind, in this case, it won't be Istio operator, it will be PR Fabric, PR orderer, Fabric CA. It will deploy automatically based on this of the configuration that we select. It will deploy it automatically. So just creating the YAML that we have created here. But this is for this operator. We will see later about the fabric. So if we check the diagram, right now this one is done. So now what we're going to do, the next step, is to configure the internal DNS because, okay, right now we have, if we go to this mapping, we have this mapping done. But what happens for the peers that are inside? So we have the PR0. We have the PR0 for the organization 1 and PR0 for the organization 2. And these are in different pods. This is a concept in Kubernetes. And they need to communicate between them. But the URL that we will have, so the PR or the organization 2 will try to connect to this one. Okay? So in order to be able to, from other containers to go to this PRO or one, is to tweak the DNS. So this one, if we don't specify anything, it will go to localhost and it will fail because it will try to contact something that is running in the local pod. But we will take the configuration so that it goes to Istio. So when there is the localhost.st will be redirected to the Istio, and then Istio will act as a load balancer and will redirect to the right PR. So that is why we need the internal DNS. So in this internal DNS, the lines that are needed is this rewrite. So basically we are rewriting everything that ends with localhost.st to the Istio ingress gateway that we have just created. And this SVC cluster local, this is to indicate that the service is inside the Kubernetes cluster. So, and if we check this service inside the Istio system, we will check that every service has some endpoints, and these endpoints are the ones that are deployed. So if we check this IP 10.42.06, then one of these will have this IP 10.42.06. So basically it will be routed to this ingress gateway, and then this ingress gateway will route it to the right PR orderer or whatever we create inside the cluster. Outside the cluster, we just need to go into localhost is good enough because we have this mapping. So next step, okay, let's create it, because sometimes what it happens is that if you are restarting your PC and then Docker is spin up and then the Kubernetes is restarted, what happens is that the core DNS is overwritten. So one common problem that happens is that you want to try the network, you restart your computer, and then it doesn't work. If it doesn't work, one of the things that I will try is to apply this config map again. And then if you can restart the peers and the network, it will help the peers to get the new DNS configuration. Because basically there is a cache internally in the peers about the DNS. So restarting the peers help get the latest DNS configuration for each node. So next step, installing the shelf operator. So in this case, we are going to use Helm. You can go here in order to install Helm. You just need to execute this script, and then you will have Helm in your computer. So I already have Helm and have this version. Okay, I think whatever version that is greater than 3 will work, but we will need to add the repository, add this custom repository. In this case, this has already been added to the repositories. I usually do this all the time with this force update, because if there is a new version, then you want to get this new version. If not, then you won't get the new version. And if you have followed these steps earlier and you don't update the repository, then you won't be able to install the latest version. So we have added it, and then we install it. I usually do a upgrade install, because in this case, if something changes, then I can just execute the same command. So right now it will be installed. If I execute it another time, then it will be upgraded. Okay. So in the meantime, there is another question. Do we need to deploy a Vault as well for managing the certificate generated from the CA? No, I mean, all of the configuration is safe as secrets. So this is something that if you want to manage the secret configuration for the users, you will need to do something. You will need to integrate with Vault with a server that you need to develop it, basically. I don't know if Hyperledger, I think Hyperledger supports Vault. So I think they manage that. But the operator, the goal of the operator is to make operations easy and to rely on Kubernetes as much as possible. So there is no integration with an external service because the focus is that someone needs to be able to spin up a network quickly. And in order to do that, the less dependencies that they are, the better. So any integration needs to be custom in this case. This was a question from George. So let's check in Lens. So we have the HLF operator control manager deployed. And if we look closely at the custom resources, there is a new item here, which is HLF Confusoftware.ts, which is the company that started this project. And we have a bunch of custom resource definition. We have one for the Fabric CA. We have another for the Fabric chain code. Everything is empty. Another for the Fabric chain code template, which is a new feature for the 1.10. Fabric Explorer is not used. Fabric follower channel is in order to be able to join peers for the peer organizations. Fabric identity, we saw it is in order to register and enroll a user in order to get the certificates and the private key. Main channel is useful to create channels. Network config is for generating network configurations. Operations console, this is in order to deploy the IBM Fabric Operation Console that they open sourced. For the Fabric Operator API, Fabric Operator UI, the only one that is you can use both, but there is a way, and this is in the documentation, in order to only use the API and to deploy both, in order to reduce the complexity of creating an explorer. And then the orderer node, in order to deploy orderer nodes in the cluster, and then the PR, self-explanatory, in order to deploy PRs in the cluster. So these are all of the resources that are available. Each of them have different parameters. The most complex one for this is the PR, which has many parameters. And well, let's get into that. So we have installed the operator. Right now, what we need to do is install the kubectl plugin, because if we check the picture, we have the HF operator, which right now is deployed. Okay. Right now is deployed. So the next step is to start deploying PRs, orders, chain codes, etc. So we need to deploy this. We need to install the kubectl plugin. What we're using is Crew in order to install it easy. So you need to execute this command if you're on Mac OS or Linux, but there are also instructions for every operating system. So once you have installed Crew, you can just kubectl crew install HLF, and that's it. So, well, in this case, I have already installed it, so it should be, I don't know, it's taking long, but maybe it's because of my connection. The installing plugin HLF. Okay, and then if I do kubectl HLF, I have already one precompiled, but it will be in home crew bin kubectl HLF. I'm going to remove it in order to not cause any conflict. And the next step is to deploy our first organization. So in order to deploy an organization, this is conceptual. We will need 3 parts. So this is an HLF organization. The first thing that we will need to deploy is the Fabric CA. Then, once the Fabric CA is deployed, we need to register the users. These users can be, so register user, PR or orderer. And then we can either deploy PR or deploy orderers or deploy both. So whatever we want. Okay. And that's it. So this is to deploy an HLF organization. And then after the PRs have been created, we can create a channel. And this is what we're going to do. So in order to create a channel, so we need existing organizations, then create channel config, then, well, but all of this, so in this case, the Fabric main channel will handle all of that. But you will need to create the network config and then submit this network config, which means this means joining all orderers, create Genesis block, joining orderers, update channel configuration if needed, etc. So in order to create a channel, first we need the existing organization. And for each organization, and as we can see here, we will have 3 organizations. In the first run, we will create only one organization, one peer organization, and in the second run, we will create the other. So the first thing that we'll need to do is first, well, environment variables. This is for the image, which you can tweak. So let's do that. I don't know if I can do this side by side. No. Okay. So deploy the PR image, CA image. Okay, so then we need to first deploy our certificate authority. So in this case, we have the storage class's local path. In order to see what storage class you have available, you can go to Lens, and then in the storage section, in the storage classes, you can see here all of the storage classes available. This is very different in Azure, in AWS, in eCube, etc. So keep that in mind. If not, the CA won't be deployed. And then we are just passing to the CA create. And if we check the CA create source code, so I don't know if I can, yeah, let's open the operator. CA create. So this is Go, and what we are creating is a Fabric CA in the operator with all of these parameters. So what this will deploy is just the YAML file into Kubernetes with some parameters. Some of them are, do you need to grab it from the right? Mm, okay, perfect. Thanks. So yeah, there are some default parameters for the Fabric CA, but we will interact with the plugin. So let's do this side by side. This will be better. Okay, perfect. So the CA create has the image which we have declared earlier, the storage class, which is local path. Also, we have the enroll ID, which this is the initial user and password in order to be able to register users. And then the host, which in this case is org1 ca.localhost.st, the domain that we talk about. And then the Istio port will be 443. This is for the gateway to know when to which port it needs to be exposed. And this 443 is a mapping for this port in the Istio operator. So we're saying that it needs to be accessed through this port 443, which will point to the node to this node port, and then we will be able to access it via our local host 443. So let's execute this. Okay, on the right. And if we go to lens, then in the pods, there is a pod being created, or one CA. In order to make this workshop faster, I'm going to also create the CA for the order organization, which is the same, as you can see, is the same, but with other name. This is the name or dash CA, which will be created, and the host is different. Okay, and I will create also the CA for the other PR organization. Okay, so right now in Lens, all of the CAs have been created, and if we go to the HLF, the custom resource definition, to the Fabric CA, let's see the one that is running. If we edit it, we see here the configuration. This is the definition, and the Fabric CA has a lot of configuration. I won't get into detail on this, but it has a lot of configuration. So it has a gateway API. This is in case that you want to use the gateway. This is not related to the gateway fabric. So this is related to the gateway resource that is being developed at Kubernetes. But in order to see some of the parameters, you can set the resources, you can set the common name, the organization for the root CA, and you can set the service. In this case, usually it's a cluster IP, and then you expose the CA using Istio or Traffic or others, or other Istio ingress controller. And the main, well, we have here the database, and this is where you can set Postgres, for example, and then the data source will need to be a Postgres connecting string. This depends on the drivers of Go in the Fabric CA. And then in the CA, we have the affiliations for that CA, but both of them are using the same database. So the affiliations will be the same for both. We have the CRL, the common revocation list, SPY 24 hours, the CCR. This is for the name host, which will be by default used. If there is an intermediate, in this case, we don't have an intermediate, and then the registry. So in this case, the identities that will be registered for the CA will be enroll, and the password will be enroll PW. And these attributes basically mean that this user will be able to register other users, which is what we want. And the enrollments, if we set -1, this means that there are no maximum of enrollments. Remember that enrollment means that the user can generate a certificate. So the ability to generate a CCR and then send it to the Fabric CA, and then the Fabric CA will return it with the certificate. And then the subject, which you can change, of course, for the CA. And the same is happens for the TLS-CA, because remember that we have two certificate authorities. We have one for signing and the other for TLS. And we will see this when we're deploying the PR. So all of these CAs are running. So we can see the pods that are also running. We have a verification script, which basically means doing a curl on the CA info. In fact, this we can see it on Google Chrome if we want. We need to click advanced, and this is the default one is the default CA is CA name, okay, which is CA, and this is the CA chain, which it's in base 64. And if we put a parameter here for the other CA, which is TLSCA, then we see the certificate authority for that CA. So this means that it's working. We can access it also for the organization one and then for the orderer organization. Okay, perfect. So let's continue. The next thing that we will need to do, let's go to the diagram. So where this step is done. Then we need to register the user, the PR or orderer, depending on what kind of organization we're deploying. So let's do it for the first organization. This is a long README, so it has almost 900 lines. So there will be much scroll. Sorry, but yeah, let's register this user. So we're registering a user in the organization one CA certificate authority, and this is the user that will be created, PR and PRPW. The type of the user that will be registered will be the type of PR, and then in order to register the user, this is the user and password that we need, and this is the MSP ID, which the MSP ID is the ID of the organization, and this will be used in the channel configuration. So let's register it. And then let's register also the others for the organization too. Okay, and also for the orderer. So right now these are registered, and if we run it again, then we will get an error. So it's already registered. So this step is also done. Okay, so now we need to deploy the peers and the orderers. So let's go to the peers. Okay, so this step is done. Well, let's go to the first organization. This step is done, and then we will deploy a peer. How we deploy a peer? Using the kubectl href peer create. We will, in order to spin up the peer faster, we will use the state database level DB with this image that is the one that we configured earlier. Then the version is the peer tag for the Docker image, which is 2.5.5. Then we have the storage class, which is the one that we defined. Then role ID, PR, MSP ID, organization one MSP. And then we need to tell the operator what user to use in order to enroll in order to get the certificates for the PR, because we need to get two kinds of certificates, the signed certificate and the TLS certificate. So these are the credentials. Capacity will be 5 gigabytes. The name of the PR will be organization one PR 0, and then the CA name, which is a combination of the CA name and the namespace, will be OR1 CA. Okay, and then the host, which are similar to the ones that we define for the Fabric CA here, OR1 CA. So in this case, will be OR1 PRO OR1, and this is the host that will be available to access the PR. And the same, so we're creating two PRs just with different configuration. The only configuration that changes is the name and the host. Everything else is the same because the CA that we will use in order to enroll the user is the same. And the user and password for the in order to enroll the user is also the same. The storage class is the same. The image is the same. So only the name and the host differs. So let's create this. And if we go to Lens, then we will see that, yeah, this is being deployed right now. And in the meantime, we will deploy also the PRs for the second organization, which are the same, but with the CA name change in order to get the certificates for the organization to MSP. And I don't know if I register this. Yeah, I think so. Okay. Then the host will be different, of course. Instead of PRO or one will be PRO or two. And then the name of the PR will be different. So let's create both PRs. And this should also be deployed. As you can see, the PRs, when they don't have CouchDB, the memory is very low. I mean, right now there is no heavy data, but with CouchDB, we will be at half a gigabyte easily without doing anything. So you can imagine. So let's wait until these PR are created. Okay, and now they seem to be created. If we go to the custom resource definition fabric PR, well, these are failed. Don't know why. But as I can see, they are created. So I don't know. They should, yeah. One thing that I do in order to force a reconciliation is to add annotations. And maybe this fixes the pro. Okay, yeah, here. Here is running. This will be running in no time. So it's a matter of time. So we have the PR. So if we go here, this PRs is done. Then we need the orderers. We're going to deploy, as we saw in the presentation, we're going to deploy 3 orderers. Orderer 0, orderer 1, orderer 2. So if we go to the deploy orderer organization, which is in the 5th step, then we have this command. So the orderer node create is very, very similar to the PR. We have the image, we have the version, we have the storage class, which we have defined earlier. We have the enroll ID, which in this case is orderer, the MSP ID, which changes for the order organization, the enroll password, which is the one that we have registered earlier. Then we have the capacity, the name of the orderer, and then the CA name in order to use in order to get the sign until a certificate. And then the host, we have the admin host, and this admin host is host for the channel participation API. So this is why it's needed. And yeah, that's it. And there is the port in order to be able to access. So let's deploy these 3 nodes. Okay, these 3 have been created. And then let's come back. Okay, right now these are running. And then in the fabric orderer node, we should see 3, but we don't see. We should see 3. Okay, right now. And they are being deployed, as we can see here. So you can see how easy it is to deploy orderers and peers. If we want to check the connectivity, it's a problem here. Well, no. If we want to check the connectivity, there is an OpenSSL command which we can use. OpenSSL as client connect, and we're connected to this host and port, and we are doing this locally. So OpenSSL, and this will have to return the certificate. This is the server certificate. If we go with this server certificate to ShareLogic, the coder, we can see the details of the certificate. And in this case, this needs to be as it's here, the TLSCA, because this is a TLS certificate, and we have the SANs, the subject alternative names, which are localhost or 2PR0. So there are a lot of subject alternative names, and we can use any of these, domains in order to communicate, and this will be valid for this certificate. So right now we have all of them. You can see the memory very, very low. Also, I'm on ARM, on a Mac M1, so uh, this should help in order to lower the resources. So we can do this verification for the OpenSSL for all of the PRs, but if if you deploy a PR and you cannot access it from your local machine, then this means that you have done something wrong in the Istio or in the configuration when deploying the PRs. So this is the first thing that you should check. So let's go back to the diagram, and then right now the deploy orders are done. Perfect. Okay. So now we need to go to the channel. We need to deploy, we need to create the channel. Right now we have the 16 organizations, but in order to deploy the channel, by the way, if there is any question, let me know, because I haven't seen many questions from long time, so I want to make sure that it's been understood. So in the HLF channel, we need, for the peer organizations, we need the sign, an admin sign certificate. We saw earlier that there are 4 types of certificate. We have the admin, client, PR, orderer. The admin is the one that it's able to create channels, to update channels, etc. So for the peer organization, we need the admin sign certificate. And for the orderer organization, we need 2 certificates. We need the admin TLS certificate, and we need the admin sign certificate. This is used to modify the channel configuration, the orderer channel configuration, and this is used to join the orderer nodes using the channel participation API that we saw earlier. So what do we need to do now? We need to generate 3 different identities. Well, 4, because for each peer organization, we need to create admin sign certificate, and for the orderer organization, which we only have 1, we need to create 2, so 4 in total. And there is a question. We have to specify all these components in the chain code, the smart contract again. I think there is a misconception there. The chain code is independent, so the chain code is a server, and it doesn't have any reference to the PR. The PR connects to the chain code, not the chain code to the PR. So that is the flow. Okay, so let's go to the part of, well, we have deployed the order already, so let's go to the step 6, which is creating a channel. So as we saw in the diagram, we need to register the admin identity first. I'm executing the commands in the right terminal. And let's create right now the 2 identities. So we have created the user, and then we're going to create for the orderer these 2 identities. That means there is a certificate and that means a certificate. And we're going to do that using the fabric identity. Okay. So actually this is using the fabric identity. And all of the identities on this workshop will use the fabric identity CRD, custom resource definition. So let's create these 2 identities on the right. And in order to see if this identities has been created correctly, then we can do kubectl get fabric identities, and these 2 are running. And the server, the secret name is the same as the name of the identity, so we can get the secret order admin sign, and then we can see that there is one created. And this is the one that we will reference in the when we create the channel. So if we go to Lens, just to show the contents of this secret, we have these two secrets, and then for each secret we have the cert PEM, which is the certificate that was signed by the Fabric CA, the key PEM, this was generated at the client side, and the root certificate authority for this certificate, and then the user YAML, which is an extra property created for the operator. And all of the secrets that the Fabric identity creates are the same ones. So cert PEM, key PEM, root PEM, and user YAML. Okay, so we have created the identities for the order MSP, and then let's do the same for the organization one MSP. In this case, we will register the admin user for the organization one. So right now it's registered, and then let's create the identity for the organization one. If we check the parameters, which I forgot, so the parameters for the identity are the name of the identity. This is for the CRD, the namespace of the identity, then the CA name in order to enroll the user, the CA namespace, which in this case is the default, the CA which will be used. So in this case, CA means that this will generate a signed certificate, and the enroll ID, admin password. So this is to be able to get the certificate that we saw earlier, and the MSP ID. So, and the same is for the orderer. We had this orderer admin sign, which was using the CA, and the orderer admin TLS was using the TLS CA. So that's it. And if we want right now, no more identities. We will need the organization 2 MSP identity after we create the channel, because the channel contains a lot of configuration. So here we have the Fabric main channel. We have the metadata, name demo. This is for the custom resource definition. And then in the spec, this is the channel that will be represented in the Hyperledger Fabric network. Okay. And we have the admin orderer organization and the admin PR organizations. So this basically means that, so this comes from the use cases and from the experience. So usually, if we have a channel, we have an organization that knows about Hyperledger Fabric, which we can call it the founder. And this is the one that manages the channel configuration, manage the organizations, peer organizations, manage also the order config, consensus configuration, etc. So, and this is what we mean by admin order organization and admin PR organization. So the admin order organization will be the ones that will need to sign the configuration update in order to update this this order part, which includes the batch size. This basically means max message count means how many transactions will be bundled into a block. We have also the batch timeout, which means if we have one transaction, not 10, so how much should the consensus wait until creating a block? And in this case, it's 2 seconds. Then we have other configuration. So this order configuration, only with this signature of the MSP, we will be able to update. And then we have the admin PR organizations, which will be able to update this part, and also the PR organization, so the members of the channel of the application. So, and there is also a section for the order organization. So the order organizations, if we need to add another organization, then only with the identity of the orderer MSP will be sufficient. And imagine if we have 20 organizations in the channel, this speeds the process of adding organization, removing organization, especially in test nets. So when you are testing configuration or when you want an easy onboarding in order to test your network. If you are in production, then you may need to tweak this accordingly. So we have the Fabric main channel with this admin organization, with this channel configuration. And then we have the peer organizations. Later, we will add the organization to MSP here and the identities that will be used. In this case, we only need 3 identities. The fourth one will be used in order to join the organization to MSP, which we haven't created yet. And the external peer organization, orderer organizations. In the orderer organization, for each one, we need external orderers to join. These are the host and the port for the channel participation API in order to be able to join the orderers to the channel. Then we have the MSP ID, the orderer endpoints, orderer node 1, node 2, node 3. This is the port. And then these orderers, in reality, these are the consenters. And for each consenter, we need to specify the TLS certificate. So that is why we have this environment variable. So in this network, in this channel, we have 3 consenters, orderer node 1, orderer node 2, and orderer node 3. And the TLS certificates are fetched from the CRD, from the Fabric orderer node. So if we execute this and then echo orderer 0 TLS search, so this is the TLS certificate for the orderer 0. And we need, in order to mark it as a consenter, they need to be in the channel configuration and they need to have a valid certificate. So we can now apply this custom resource definition. In this case, we're not using the kubectl HPLI Fabric plugin because the configuration is complex. So let's create it on the right. So Fabric main channel created, and then we can get the Fabric main channel. So the channel has already been created. So this is good. And if we go to the lens, then we can check in the orderers if there is some log activity. So yeah, creating block 2. So there is activity not in the organization 2 peers. So the organization 2 peers are not, well, there is a gossip, but I think this is between the organization, the organization 2. So yeah, because we haven't yet joined the peers to the channel. So which this is the next step. So we need to join the peers from the organization 1 to the channel. So in this case, we need to get the orderer 0 TLS certificate. Let's add it here. And then we need to create a Fabric follower channel. So the convention that I use here is to have the channel name dash the organization. And this way, there will be no duplicates. So in this follower channel, what we will set are the anchor peers, which are the peers that are well known to the channel for the organization 2 when he joins to be able to find the organization 1 peers. And then the HLF identity, which will, this is the one that we have created earlier in order to be able to join the peers to the channel. And then in order to get the Genesis block, we will need to have access to at least one orderer. So with one orderer is good enough. But in order to connect securely with that orderer, then we need the TLS certificate of the orderer 0. And then, of course, the MSP ID, which is the organization 1 MSP, and the channel to join, which basically this channel will be the one that will be requested to the orderer and the orderer will only reply with the Genesis block if this identity is authorized in the channel. So there is security involved. We cannot just join any organization. So let's execute this, and then let's get the Fabric follower channels, and then we can see that this is running. And if we go to Lens, then we see that creating ledger demo, so a committed block 5. So there is activity in the organization 1 PR 0 and also in the organization 1 PR 1. There should be. Perfect. And then in the organization 2, still no activity. But let's join the organization 2 already. So in order to join the organization 2, we need to only add a line, an item to the peer organization. So in this case, instead of organization 1 MSP, it will be organization 2 MSP and organization 1 CA to organization 2 CA. And that's it, because the CA namespace is the same. So let's reapply this Fabric main channel. Okay, Fabric main channel configure. If there is any error in the configuration, then the Fabric main channel will switch the state from running to fail, but in this case it's running, so this means that the change has been applied. And if we want, we have here demo config, which is the latest channel configuration, and this is a JSON, a big JSON, and here the organization 2 MSP is located. So yeah, we now we're sure that the operation has been correctly processed, and as we have joined the second organization, then we can join the peers. We're able to join the peers. So first thing that we need to do in order to join the peers from the organization 2 is to first register the admin, okay, in the organization 2 certificate authority, and then enroll it, creating the Fabric identity. Then we have created the identity. We can go to Lens, and then we can see the Fabric identity, and we can see that it's running and the secret has been generated, as we saw earlier. And now we can create these Fabric follower channels with the anchor peers. Instead of the anchor peers being the one for the organization 1, these are the ones for the organization 2. The order is the same, and then the peers to join are the ones for the organization 2. So if we execute this command, what is the follower channel and what is the purpose of creating it? The purpose of creating the follower channel is in order to join the peers to the channel and to configure the anchor peers in the channel. So right now, if we go to the config map, there is a new one that has been created, the demo org2 MSP follower config, and this is the channel configuration, which is in JSON. And here we have the anchor peers for the organization 1 and the anchor peers for the organization 2. This is what the Fabric follower channel does. If you don't set anchor peers, then you won't be able to approve and commit the chain code based on my experience. And if you don't create the Fabric follower channel, then the peers won't be joined to the channel. So that is the purpose. So right now, if we check the organization 2 PR1, then we see that there is some activity, committed block 11. So if we go to this diagram right now, well, there should be another box created Fabric follower channel, and this means joining the peers, the org peers to the channel, and configuring the anchor peers. Okay, so these two are green. So what is left? we have created the organization, we have created channel, so what is left is deploying a smart contract. And in order to do that, we have three steps. So we have the part where we install the chain code. We have the part where we approve the chain code definition for each organization, for each org, PR org, not all of the organization, but for each PR organization. And then finally, we commit the chain code definition. Once a majority of orgs have approved. So if only one organization approve, then we won't be able to commit the chain code definition. So we will start with installing the chain code in all of the PRs. So let's go back to the workshop. So install a chain code. We need to prepare the connecting string, and this is where Fabric Network Configs comes into play. So we will need to create two identities because we will create two network configs, one for the organization one and the other for the organization two. So the identity, in this case, the Fabric identity will also register the user. Okay, so I won't get into detail to this because we're running late, but we need to create. Well, right now these two identities are created, so there is no need. But we need to create these two network configs. Let's create them. And then let's go to the lens, Fabric network config. And then we have these two network configs. And if we check, and in this network config, there should be a property which is the secret name, where the connection profile is saved. So let's go to the secret. And then these are the two secrets for the network config. And this is the connection profile, which contains information about all of the organization, the peers. It also contains, in this case, this is the organization one. It contains the users. So all of this. And what we will do is fetch the connecting string for the Kubernetes secrets. So let's download it using this command. Basically, what we're getting is the config YAML. So right now we have locally the organization one YAML, and we can see this better than in Lens. So we have all of the organizations here. Well, not organization two, only organization one and the orderers, and then the peers, and then the certificate authorities, and then the channels. And in the channels, we have these orderers will be used, and then this PR will be used. There is no need actually to get the PRs from the other organization to this connection profile because the discovery service takes care of that. So this will be fine. So we have fetched the network configs, this step. So now is the time to install the chain code. I will execute this and then let's comment it later. Package ID installed. So what this created is the chain code set, this one, development finder. And if we extract this chain code, we see that it has two files. One is the code, which contains the connection JSON. And if we see this, let's see it better in the Visual Studio Code. So this connection JSON will be the one that the PR will try to connect to in order to access the chain code that we're installing. But in order for this connection to work, we need to deploy a Fabric chain code into the Kubernetes cluster. And then we have some properties, dial timeout when connecting, and then If it needs TLS, since we are in local communication in Kubernetes, then we don't need TLS. Then we have the metadata. In this case, this is type chain code as a service. This means that the PR will try to connect to this address, and this is why we need to go to this address, and this is why uh, we need to connect. We need to specify this address, and also we need to specify this metadata at the chain code as a service. And the label is just a metadata for the. I mean, it is for referencing this because we have here chain code installed, so this is the label asset colon, and then this is the hash of the chain code package. So if we do C SA256 sum, okay, we will see that this matches. This starts with df and ends with 3b. So this is the first step. Then the second step is approving well, we can check if the chain code is installed, and this takes the configuration profile that we have seen earlier, the user, which is the one that is present in the connection profile, and then the PR that we need to check the chain codes from. So in this case, we can see that the package ID is present, and it should return something like this. By the way, there is I mean, for the people that are here, there is a course that I launched, and we explain this in detail. So yeah, if you are really interested and want to take it to the next level, then make sure to check this course out. So it has a discount for the first people. So yeah, make sure you check it if you are interested. I won't say anything more. And okay, so first the next step is deploying the chain code container on the cluster. This is for this connection JSON to work. Asset colon 7052. So we need to deploy the external chain code. The chain code name is the one that we declared earlier, which is asset, as we can see here. And then the image, this is some image that contains a chain code, which I have published earlier. So, and the package ID, this is very important. So let's deploy it. Create the external chain code asset. So this is also a resource from the operator. And this is, in this case, is Fabric chain code. So it will deploy the asset chain code, and we will have in the service an asset service, and with a port 7052, which will be the one that the PR will use to connect to the chain code and execute transaction. So the next step, while this this chain code is already running, so this is perfect. I think this is in Go, so there are no logs, but we will see that it's working. So we need to approve the chain code, and we need to approve it for both organizations. So in this case, let's put the endorsement policy to both. So I can put it to both, and so both organizations need to endorse, and we need to approve it uh, for each organization. This endorsement policy means that both organizations should endorse the transaction. If I put this, or this means that either organization 1 MSP or organization 2 MSP, if organization 2 MSP signs the transaction is good, and if the organization 1 MSP signs the transaction is good. So there is no need to execute the chain code in both organizations. So this is the policy that is passed here in the policy, endorsement policy. The version and sequence will start by one, but if we want to change the endorsement policy later, we need to increase the sequence if this changes. And then we have here the channel, and then the name of the chain code that we're approving. And then here at the start, we need to configure the connection profile in order to be able to connect to the peers, then the user, and then the PR. Okay, so let's execute this. Okay, I need to declare the variables. Let's execute this. So approving for the first organization, chain code approved. This is the transaction. So for every approval and commit, there is a transaction involved. And then approving approving the chain code for the organization too. So now the chain code has been approved. So at this point, we have approved for each organization. We have installed. Let's fill this in green. And then we can, once the majority of organizations have approved, we have two organizations. So this is met, and we can now commit the chain code definition. So let's commit it. The chain code commit parameter. Well, we have a problem. I don't know. Yeah, right now it's committed. There should have been some problem with the connectivity. So the chain code commit is almost the same as the proof for major, but since the package ID is per organization, because every organization could have different chain codes, and the chain code, as we saw earlier, is the hash of the chain code TJZ. So every organization can have its own package ID, but when it comes to committing the chain code definition, the global chain code definition doesn't contain the package ID. So this is why this is not included here. And then now we can invoke a transaction in the channel. So we can do it as the organization one or as the organization two. We will see, so let's execute this this command. So this is kubectl hlf chain code invoke. This is the connection profile, organization one YAML. This is the user to use in order to sign the transaction proposal. The PR that will be used for endorsement, but others could be used also. Then the chain code, which we want to go to execute, in this case, the asset. If we, for example, if we set another one, then this will fail. So this is a common error. Someone will say that they don't know this chain code. So yeah, well, basically it won't work. So as you can see. So we can do the same for the organization too. So the transaction ID is the same. Right now, the ledger is initialized, and there are two types of operations here. The invoke, which generates a transaction, and therefore can, in this case, can modify data in the blockchain. And then we have the query. As you can see, the invoke takes long time because it needs to wait until the block is finalized. And as there are not many transactions, and the maximum transactions in a block are 10, and we are right now executing one, then it wastes 2 seconds, which is the batch timeout that we configure here in the Fabric main channel. So this is why it's taking so long. And then the query only goes to the PR, and this returns immediately. The query took 5 milliseconds, so it's very, very fast. And what the query does, we have here the SDK client, we have the Fabric PR, and we have the chain code. So the query only does this, and then the chain code returns the data, then the PR returns the data. Okay, but the difference is that when we're invoking a transaction and we want the data to be stored, if this is using the Fabric gateway, it will go to the ordering service, submit transaction. Or the SDK client can submit also the transaction. So that will be the catch. So when you submit a transaction, then it needs to this SDK client needs to wait until the transaction is committed in a block. So that is why for the invoke it waits and we have a transaction ID, and for the query we only have the return. So query is usually used in order to query data, to get data from the blockchain, and invoke is used in order to create data or update data, etc. And then we can create an asset. Okay, then 2 seconds, and this will be, we have the transaction ID, and then we can query an asset. And then we can query an asset that doesn't exist, and then it will throw a transaction. The asset, and this is from the chain code. The asset 333 does not exist. So so this is the completion. So right now we want to do the QA of the questions that you have. So let's start. After deploying to the Kubernetes in order to access the blockchain through, let's say, an API, we have to deploy. We have to deploy that in Kubernetes as well and use Istio to get access to the endpoints. It's recommended to use the same Istio, the same ingress controller. So if you use Istio, then if you are accessing an API, then it makes sense to use Istio. Because if you are in Azure or AWS, then you have to unify the entry point to the Kubernetes. So having Istio and Nginx doesn't seem, it seems like a waste of resources, to be honest. A question from YouTube. After all the orgs approve the chain code, if you want to update the chain code, do they need to approve again? This is interesting because you can just, using the external chain code as the chain code as a service, you can just update this. So you can just update the image. So let's say that you have a chain code image, then you just update it and then you redeploy it, and that's it. And but usually the organizations are separated, so each organization has its own chain code, especially if it's decentralized. So usually when it's truly decentralized, it involves a new approval. But if you want in this workshop to update it, then just compile a valid chain code, create a Docker image of a valid chain code, and yeah, that's it, and run this command again, having changed this image. So you don't need to install it again because installation is done, and uh, you have already the address set here for the chain code. So you just update the image and it is redeployed, and then the new code is available. Okay, so from Carlos, where is the data stored in the chain code? No, the chain code is it's not stateless because it relies also in the state database. This is a in-depth conversation. But the data is stored in the PR, and this is what we saw at the start of the meetup. We have in each PR we have the state database, the block storage, and the history database. So in this case we have the blocks, which are stored in all of the blocks. So we check the lens, the logs for the organization too. So we see here that receive block 36. So this is where the data is stored, but when a block is received, the state database is updated. So that is a catch. But the data is always stored in the PR. When you deploy a certificate authority step for one, the host is set it as organization one CA. What if they install the HLF network into a virtual machine in cloud and we want to connect with SDK and create an API? Well, that in order to do that, you will need to handle basically the SDK, the virtual machine needs to be able to connect to the Fabric CA in Kubernetes. So you will need to have this, I don't know if it's here, it's in the page 2. So this user, which will be your VM, will need to have connectivity to Istio. But if you want to deploy in a cloud, it's very different. So, and you can I mean, there is not a unified way. I did this, so my plan is to upgrade it and to bring workshops to this course. So I'm the creator of this course. So if you purchase this, then we'll make sure to ask all of the in-depth, not in-depth question from the workshop, but in general, you have a way to ask me anything here. So from George, Fabric main channel, Fabric follower channel. Is it the same as system channel as an application channel? No. The system channel is not supported in the operator. So we support only the channel participation API. The system channel is not used. So the Fabric main channel creates the channel, and the Fabric follower channel joins, as we said here. The Fabric follower channel joins the organization peers to the channel, but they don't modify the channel configuration. Well, they modify the channel configuration only for the anchor peers, but these anchor peers are meant to be configured per each organization. Because if for each peer organization we needed to agree with the other organization, it will be a mess. So the anchor peers are only need the current peer organization signature in order to be able to be updated. And then the Fabric main channel is the one that creates the Genesis block, joins the orderers, and then update the channel config if needed. So this means that adding new peer organization, new orderer organization, or removing peer organization, managing the consenters, etc. So basically the configuration that you can see inside the Fabric main channel spec. So it's not like the system channel, George. Any other question that you may have? Anyone? Well, I don't know, David. Yeah. You want to? Thank you.
Yeah, thank you, David. You're all set?
Yeah, I'm
Great.
all set. I mean, if there is no additional question, then thank you everyone for being here, and you can find me on LinkedIn.
Yeah, thank you, David. And I've sent those resources out to everybody who signed up who wasn't able to join today. So
Okay, perfect. Thank you.
great. Well, thanks everyone.
See you in the next one. Bye.